Now we are going to discuss in physics subject another chapter. In the previous class we completed the light chapter. Now we are going to discuss sound. In that sound chapter, before going to discuss the sound, now we are first to discuss waves chapter. First, what is wave motion? That is transmission of energy from one point to another point. Transmission of energy from one point to another point without any actual displacement of the medium particles, called as wave nature. Suppose one wire is there, one thread is there, one side it stick to one nail, which is very loosely fixed into the wall, loosely. That's the one nail. One side it is right bind to that one, and another side if we do like transmission of energy from one point to another point, that a nail comes outside. Transmission of energy from one point to another point. Is there any, what is the medium here? The energy is transmitting through that wire, through that thread, from A point to B point. Here, is there any displacement? Here, the thread becomes thin, in the corner it becomes thick. No, that is no displacement of medium particles. Transmission of energy from one point to another point, that mechanism is called as wave motion. That is transmission of energy without any actual displacement of the medium particles. Due to the vibration, with the vibration, the transmission of energy from one point to another point. Transmission of energy with the vibration from one point to another point, transmission will be takes place without any actual displacement of the medium particles. That is called as wave motion. Suppose the water is in rest. Suppose if we drop one m mass containing stone, if we drop one stone into the water, now that stone occupies area, that is push the water and occupy this much of area. Already in that place water is there. That water is push the side water. That water push once again the side water. Once again pushing. Once again the energy is transmitting from this point to on that point. Due to gravity, that stone is falls downside. Once again the stone area is vacant. That water comes to once again initial position. Now in this position the vacancy will be takes place. That side water comes here. In that place vacancy will be takes place. In that method water comes front side direction as well as in the backward direction. That is transmission of energy from one point to another point without any actual. The water once move in this direction, once again comes to as it is position, right? That is due to vibration, the transmission of energy will be takes place. If we observe, suppose 6 persons are in line. Suppose the backside candidate push me. Now I fall down like. Now I push the front side candidate and once again comes to rest position. That is a transmission of energy from one point to another point. The front side candidate also, right, push the front side and once again comes to rest as it is actual position. There is a transmission of energy from one point to another point without any actual displacement of the medium particles called as, right, wave motion. In this wave motion, the waves are classified into two types. One is longitudinal, another one is the transverse waves. Suppose it is the, in this thread, it is the passing direction. What is the medium here? That thread. The vibrations of that thread is perpendicular or insimilar. See here, it is the passing direction. It is a passing direction. The vibrations are perpendicular to each, perpendicular to the passing direction. The vibrations are perpendicular to the passing direction. That phenomenon is called as transverse wave mechanism. It is the passing direction of energy, energy passing direction. The water is the medium. Once water moves in upward direction, that is crest. Once in downward direction, trough, crest and trough. That is the vibrations of medium particles, that is the water particles, perpendicular to the passing energy direction. That type of is called as transverse waves. What about in longitudinal waves? Suppose here 6 members are present in line. The backside candidate pushed me. I front side I push back. I pushed and once again comes to rest. Once again the front candidate also falls downside as well as push the front candidate once again comes to rest. That is the transmission of energy from one point to another point. Here the vibrations of the medium particles are here persons. It is the passing direction, energy passing direction. What about the vibrations of medium particles? Mediums nothing but particles, that is the persons. The persons are moving up and down or in the same direction, right? The vibrations are in the along with the same energy passing direction. It is the passing energy direction. The vibrations of the persons are in the same direction, not in perpendicular. If it is perpendicular, called as transverse waves. If it is in same direction, called as longitudinal waves. Example is the wave passing through the persons who are present in the line in the serial called longitudinal waves, as well as in the spring waves. Spring waves also example for the longitudinal waves. If we apply the force, the passing energy direction is in this direction. Now the medium particle is that spring. The vibration is front and back, that's why in the same direction, that's why longitudinal wave. Another one is, suppose the sound waves. The air layers wise structure, A, B, C, D, E, layers wise structure. Suppose it is the blade. Suppose if the blade, if it is bent, the A comes to front direction, A place is vacant. To occupy the A place, B comes to front side. Now the B place is the vacant, C comes to front side, C will become vacant, D comes to front side, once again E comes to front side. Now the blade, it will be blade, once again comes to actual position. What will happen? Now once again A, B, C, D, E, F, A comes to its initial place, but in that initial place already B is there, pushing off B layer. Once again B goes to its initial place, that is the C. The B place is occupied by the C. B is pushing the C. Once again, that is the energy is passing through the air. Now I am releasing the sound energy with I am doing vibrations within air. Within air, I am pushing the air. That air, the vibration, the energy is passing through the air and reaches to our eardrum, and the vibration will be takes place. The sensation of hearing will be takes place to us. Right here, it is the energy passing direction. Now the vibrations are in same direction only. That's why it is also example for the longitudinal waves. Waves are two types: longitudinal waves, transverse wave. If the vibrations of the particles in the similar direction, longitudinal waves, in the vibrations of the medium particles are perpendicular to the passing direction, called as transverse waves. Example is another light waves. It is the energy passing direction. Electric component in this method, that is a perpendicular to the passing direction. The magnetic compound is in this direction, that is a perpendicular to the passing direction. Right, that's a light waves are example for the transverse waves. Right, here the waves are classified into another two types based upon further propagation. Medium is compulsory or not. Based upon that one, the waves are classified into mechanical waves, electromagnetic waves. Mechanical wave first. For the propagation, medium is compulsory. Those waves are called as mechanical waves. For the propagation, no need of medium, called as electromagnetic waves. Example, light waves. Why? Because from the sun to the earth surface, vacuum is there. Just 1000 kilometers of atmosphere is there around earth. Remaining all are will be the vacuum because of here between the sun and the earth 150 million kilometers of distance is there. That is the 15 crores of kilometers. 149.7 million kilometers approximately. Now 1000 kilometers of atmosphere is there. Out of the atmosphere is the vacuum. Now from the sun surface to earth, reaching the sunlight to the earth surface. That is, here there is no medium, but light is propagating. That's why for the propagation, no medium is required for the light waves. Those type of waves are named as electromagnetic waves. Here in the sun, nuclear fusion chemical reaction takes place. Nuclear combination chemical reaction, nuclear fusion, nuclear addition. That is a combination of small hydrogen nuclei. As a result of hydrogen nuclei, we are getting a helium molecule along with some amount of solar energy will be releases. That is, sun is an example for the hydrogen bomb. Per every second, 66 lakhs of million metric tons of hydrogen is consumption. Addition will be takes place. But we are hearing the sounds of hydrogen bomb or sun. No, why? Because for the sound waves, for the propagation of sound waves, medium is required. Now here medium is not there. That's why they are not propagating, not reaching to the earth surface. That's why the example for mechanical wave is sound waves. For what is the mechanical wave? For the propagation, medium is compulsory. Without medium, they can't propagate. Those waves are called as mechanical waves. In presence of there is no need of medium for the propagation. Those type of waves are named as electromagnetic waves. Example is light waves. Next, another classification of waves are into four types. One is forward waves, that is they move in the front direction. Backward, nothing but they return to the source of this sound, backward waves. Another one is the damping waves. That is as the passing distance is going on increases, the intensity is, if it is decreases, those type of waves are named as damping waves. Example is sound waves are the example for the damping waves, sound waves. Why? Because as the passing distance is going on increases, the intensity of the sound will be decreases, damping waves. Another waves are stationary waves. Stationary waves means, suppose an wire is there which is fixed between 2 points. That is a tensed wire, tensed thread that is a fixed between any 2 points with some force. That is, if we vibrate, it will be vibrates in this method. The loops will be generates. It is the forward wave. It is the suppose it is a wire it is which is fixed between 2 points. That is a tensed wire. It is a forward wave when it is reaches to the final point and once again return to the starting point. That is, these type of waves are named as stationary waves. That is, all musical instruments are made up of stationary waves only, almost. As well as one side closed, another side open glass, water reservoirs like well or glass in that instruments. Really, in that instruments, the producing waves are stationary waves. Stationary waves means the forward wave and the backward wave are overlapping with in constructive manner. That is a formation of loops. It is called as one loop, another loop, loops. Suppose just the thumbs up bottle cap, the lid of the thumbs up bottle, if we done 2 holes through that one thread, if you rotate, it will, if you do like, it will be appears to us in the loops. That loops are belongs to stationary waves, right? Here the longitudinal waves are propagates in the methods of, it is the close to each other. At this point, once again relax, once again close. It is close, remaining all are normal. That's why the longitudinal waves are passing in terms of compressions and rarefactions. The longitudinal waves are passing in terms of compressions and rarefactions. The transverse waves are passing in terms of crests and troughs. It is the high amplitude crest. It is less than the normal level, below to the normal level. That is a trough. Crest and trough. What about the stationary waves? In the form of nodes and antinodes. Right, here the longitudinal waves, compressions and rarefactions. What about the transverse waves? In the form of crests and troughs. What about in the stationary waves? In the form, with the name of nodes and antinodes. That is, what is the wave transmission of energy? Transmission of energy from A point to B point without any actual displacement of the medium particles. That is called as wave. Here, in all the waves except than stationary waves, energy is transmitted. But the medium particles are in normal position, in the constant position, without any actual displacement of the medium particles. Here, what about here? The forward wave carrying energy reaches to B point. That is the transmission of energy. Once again, the backward wave brings that energy into the once again A point. That is net displacement of energy as well as medium particles is not there in the stationary waves. Net displacement. Energy transmission is there, but traveling the energy, carrying the energy from A to B in the pattern of forward wave, once again B to A in the backward wave, once again return to the energy once again to the A point. That is a net displacement of energy as well as net displacement of medium particles, both are will be zero, right? Right here. Suppose these are the transverse waves, crest trough, crest trough, crest trough, crest trough. What is the wavelength? One total crest plus one total trough called as wavelength, or the distance which is present between the two adjacent crests, or the distance which is present between the adjacent troughs, or the distance which is present between the two points in the wave which are in the same phase. Lambda, it is called as, it is a Greek word, wavelength. The units commonly we measure in angstrom units or nanometer or meter, centimeter, right? There is a length measuring unit. Question will be like, here in the stationary waves at A point the displacement is 0. In this, at A point the displacement, the amplitude is 0. At here also 0, the amplitude is 0. Those points are named as nodes, where the maximum amplitude, if it is there, anti-nodes. Question will be like, suppose from here to here lambda, one wavelength, from here to here lambda by 2, right? Suppose here from here to here lambda by 2, from here to here lambda by 4, lambda by 4, lambda by 4 plus lambda by 4, lambda by 2, lambda by 2 plus lambda by 2, lambda, right? Similarly, question will be like, here between two crests or between adjacent two troughs is wavelength lambda. Question will be like, suppose here the distance which is present between the node and anti-node, the distance is simple lambda by 4. The distance which is present between the two, that is a node and anti-node, is lambda by 4, or the distance which is present between the two nodes is lambda by 2. The distance which is present between the two nodes or two anti-nodes. The distance which is present between the two nodes is lambda by 2. The distance which is present between the two anti-nodes, lambda by 2. The distance which is present between the node and the anti-node is the lambda by 4. Right? Question forms like, right here the waves are classified into first two types: longitudinal waves, transverse waves. First, what is the wave nature? Here suppose one thread, if it is one side, bind to one nail which is loosely which is loosely present on the wall. Suppose, right, if we do like that, nail comes to outside, there is a transmission of energy from one point to another point. Transmission of energy. Is there, what is the medium here? Thread. Is there any, the thread particles are moving that side? No. Here the thread becomes thin, in that becomes is there any thick? No. No transmission of medium particles, but transmission of energy from a point to another point, called as wave motion. Here the persons are in the line. Suppose 6 persons are there. The backside candidate pushed me into the front side. I will like once again pushing the front candidate, and once again comes to as it is. There is a transmission of energy. The front candidate also same. Pushed by the back candidate, once again push the front and comes to as it is. That is a transmission of energy from one point to another point. But it is a displacement, but actual displacement becomes 0. Vibration to front side and once again comes to here. That is, actual displacement is 0. That is called as wave motion. Based upon the transmission of energy. It is a transmission of energy in this direction. In this direction, the vibrations of the particles in the same direction, longitudinal waves, perpendicular direction, right, transverse wave. That is, the vibrations of the particles are in the direction of the passing energy direction, called as longitudinal waves. If the vibrations of the medium particles are vibrating perpendicular to the passing direction, called as transverse wave. Example for the transverse waves are water, the waves which are present in water, as well as the waves in thread or wire, as well as light waves. The transverse waves are passing in the with the name of crest and trough. What about the longitudinal waves? Compressions and rarefactions, right? The example is the waves which are generated in the persons who are present in the line, as well as the spring waves, as well as sound waves are the example for the longitudinal waves. What about the classification of waves into 2 types, mechanical waves as well as electromagnetic waves, based upon the medium for the propagation. If medium is not compulsory for the propagation, called as electromagnetic waves. In presence of medium only, without a medium they can't propagate from one point to another point, called as mechanical waves. For the mechanical waves, example is sound waves, right? Another waves are forward waves, which moving front side, backward waves which are returned to the once again source. There is a damping waves. As the distance, as the passing distance is going on increases, the intensity, if it is decreases, called as damping waves. Next, another waves are stationary waves. That is a transmission of energy, carrying of energy, and once again reaching to the end point, and once again by the help of backward waves, due to the superimposable the front side and backward wave in the constructive manner. That is a once again moving front wave and backward wave, right? Those are combining and forms loops. These called as 1 loop, 2 loop, 3 loop, 4 loops, right? Without any amplitude, called as nodes, with a maximum amplitude, called as antinodes. In the stationary waves, net displacement of medium particles 0, as well as net displacement of energy transmission also 0. Why? Because the forward wave carrying the energy and once again bring back to the initial point. Shall we say net displacement of both will be 0. There is a transmission of energy as well as the displacement, actual displacement of the medium particles also, both can be 0. In the remaining all the waves, energy will be transmission from one point to another point. Here energy also transmitted, but once again bring back to the initial point, right? That's why in the both will become 0. Question will be like, the distance which is present between the 2 nodes or 2 antinodes is the lambda by 2. The distance which is present between the adjacent node and antinode is lambda by 4, right? Now question will be like, sound waves are option A, longitudinal waves, option B, mechanical wave, option C, damping wave, D, all the above. Now the answer is all the above. Why? Because sound waves are mechanical waves, longitudinal waves in the air. The sound waves are in air, longitudinal waves. The sound waves in water and solid, that is a liquid and solid medium, those are transverse waves. Sound waves are in air in the form of longitudinal propagation. The sound waves which are propagating through the liquid and the solid, that is the water and the steel, in the form of transverse waves, right? Now the sound waves are mechanical waves in the air, longitudinal waves, as well as damping waves. The longitudinal waves are passing with the name of compressions and rarefactions. What about the transverse waves? Crust and trough. What about the stationary waves? Nodes and antinodes, right? The distance which is present between the adjacent crests, lambda, adjacent troughs, lambda, total crest plus total trough which are adjacent to each other, lambda. The distance between only one crest is lambda by 2. From here to here, lambda by 4 plus lambda by 4, lambda by 2, lambda by 2 plus lambda by 2, lambda, right? In that method.